Today we're going to talk about another model for exponential growth, and that is called compounding interest. So compound interest is paid on an initial investment called the principal, and the formula we use for that is this: A equals P, and then parentheses 1 plus R over N raised to the N times T power. So this looks a little bit like the model that we looked at the other day, where we added the growth rate or the decay rate to 1 and then multiplied that by the principal to get our answer. So this is just going a little bit further. The only difference really is we have that n. We have that n in the denominator. You're dividing your rate by n right here, but then you're also multiplying n times your time up in your exponent. So a little bit of a difference from the previous ones. So A is going to be your ending amount or your final value. P is your principal or starting value or initial investment. R is your rate, just like it was in the other problems. Rate, and that is a decimal. Remember, always convert your rate to a decimal. Now, N, this is the new part. N is the number of times compounded per year. Compounded per year. And we're going to get that from these values that we're going to fill in here. And T, of course, is always our time. So a lot of the same information from the previous models, except this N value. So what we're going to do is we're going to look at this table over here, and depending on what the problem says, your interest is compounded, that is going to tell you what your N value should be. So if the problem tells you that your interest is compounded annually, that means your N value is going to be 1. You know, semi-annually, kind of like a semicircle is a half a circle. Semi-annually, your interest is compounded 2 times a year. So your N would be 2. Quarterly, you know, if you think about it, there's 4 quarters in a dollar. There are 4 quarters in a year. So if you're being compounded quarterly, your N value is 4. Monthly, there are 12 months in a year. So your N value would be 12. Weekly, there are 52 weeks in a year. And then daily, there are 365 days in a year. So the problem will tell you how often your investment is compounded, and then that will tell you what your N value should be. So let's look at some examples. Number 1 says you put $250 savings in a savings account that earns 4% annual interest compounded yearly. You do not make any deposits or withdrawals. Write a function that models the money in the account. So we're trying to figure out how much money we will have after a certain time period. So our initial investment was $250. So that's my P. That's my starting value. So 250 times 1 plus our interest rate is 4%. 4% is 0.04. So 0.04 divided by our N value. Well, because we are compounded yearly, N equals 1. So 1 close a parenthesis, and then 1 times t, because we weren't given a time in this problem yet. So this is the formula we would use if we were given a certain time frame. We would then plug that in for t to figure out how much money we would have. In letter B, it says how much will your investment be worth in 10 years? So our t is 10 years in part B. So A equals 250 times 1 plus 0.04 over 1 times 1 times 10. When you're typing this in the calculator, and let me show you, you'd be correct by saying, oh, why do we have to multiply 1 and 10? That's easy, just 10. But if your n value is different, that means your exponent is going to be different as well. So the way I type it in is I do 250 and then parentheses 1 plus 0.04 divided by my n value, which is 1. And then in your exponent, I like to put parentheses 1 times 10. If you set it up like this, then no matter what your n value will be, you're going to get the correct answer. So I hit enter and I get $370.06. So this equals $370.06. So now let's look at number 2. It says 5 years ago, your parents put some money in an account to help you pay for college. The account earns 2% annual interest compounded weekly. So I probably should start underlining some things. So 2%. People will get confused when it says annual interest. That's not how often this is compounded. It's compounded weekly. So that means your n is 52. They do not make any deposits or withdrawals. There is now $55,257.50 in the account. How much money did your parents put in the trust fund account 5 years ago? So that part that says 5 years ago, that means t is equal to -5. Your r value is going to be 0.02 because that's what 2% is as a decimal. So then we're going to have A equals, our principal is $55,000, $55,257.50 times 1 plus R is 0.02 divided by N, which is 52, raised to the 52 times -5 power. So I'll type this in the calculator as well so you can see how this looks. So 55257.50 parentheses 1 plus 0.02 divided by 52. 52 times -5. So we get pretty much $50,000. $50,000 in 1 cent. So A equals $50,000 and 1 cent. So there is your answer. So all of this stuff, it looks way more complicated than it is. You just have to get good at plugging in the values in the correct spot for the formula. So let's look at the third page. I'm going to have you guys try some of these to determine, is it better to compound something quarterly, monthly, or daily? So we have an initial deposit of $2,000, and so it's going to be our P value. 3% interest, that is 0.03, and 10 years, that means t equals 10. So that's almost all of our information. So what I'm going to do is I'm going to give you the n values. So quarterly, n equals 4. Monthly, n equals 12. Daily, n equals 365. So what I want you to do is I want you to figure out the amount of money you would have for each situation. So for letter A, you have your P value, which is 2,000. You have your R value, which is 0.03. Your N value is 4, and your T value is 10. So set up the formula and then solve it, and then go on to letter B, where N is 12. Everything else stays the same. And then C, 365 is your N value. So go ahead and try these. Pause the video, and once you're done, unpause it and check your answers with mine. So you can check how I set the problems up, and then you can check the answers. And hopefully you guys got the same thing. If your rounding was a little bit off, that's okay. It's no big deal. But you should have gotten something around these values. So which is the best investment? Well, letter C was the best investment. But what I want to point out is that the difference wasn't all that much. You know, the worst investment was quarterly and the best investment was daily, but the difference is only $3 at the end of it. So what I want to point out is that in real life, when you go to the bank and you're not offered daily or weekly or something that is compounded a lot, that doesn't necessarily mean you should run away, because quarterly you're only losing $3. So don't walk away only for the reason of, oh, I'm only getting my money compounded quarterly and I really want daily, because what some banks may do is they may try to mislead you and say, oh, here's an account where it's compounded daily, but then maybe the interest rate could be lower, and then you may not make as much money. So you have the tools to do the math and say, well, yeah, maybe I'm getting my interest compounded less frequently, but I have a better interest rate, and that might be better off in the long term. But if all things are the same, if the interest rate is the same and the time is the same, the more often that your money is compounded, the more money you will have, the more money you'll make. So more compounding will give you more money. So going off of that, what if we compounded continuously? What compound continuously means that you're always or constantly having your interest compounded. And there's another formula for that, and it looks the same, except we have something called the letter E, or Euler's number. It's a button on your calculator, and we will be using that in these formulas. So when your interest is compounded continuously, you have this formula: A equals P times E raised to the RT power. And just like with the previous formulas, A is your final amount, P is your principal or starting amount, starting value, your R value is your rate as a decimal, and T is your time. So if we look at our examples here, you deposit $3,000 in an account that pays 3% interest, annual interest, compounded continuously. That means you're going to use this PERT formula right here. how much money will you have after 10 years? So our P, our principal, is 3,000. Our interest rate is 3% or 0.03. Our time is 10 years. So we would plug in these values to the formula, and we would get A equals 3,000 times E raised to the 0.03 times 10 power. So I'm going to show you where that button is on your calculator. So in your calculator, let's type 3,000. And if you look to the left of the number 4, you see the ln. It says ln. And then right above that, you see E raised to the x power in blue. So that means you got to press second in that button. So you see we have E raised to some power. Well, now we can type in 0.03 times 10. And we get $4,049.58. Okay. So that is your answer. So this is just another formula that you're going to be using. And I know it can be confusing. Say, well, how do I know if I use this PERT formula or the formula with the N in it? And you have to look for the word continuously. If it does not say compounded continuously, then we have to use the formulas that have our N value in it. Letter B, you deposit $4,800 in an account that pays 6.5% interest annually. All right, letter B says you deposit $4,800 in an account that pays 6.5% interest, annual interest compounded continuously. What is the balance after 3 years? So 6.5%, people mess this up a lot and will say, oh, that's 0.65. No, if I had you guys say 6%, I know you would say, oh, that's 0.06. This is just, another place further. This is 6.5%. So the decimal equivalency for this is 0.065. Time is 3 years, and this says compounded continuously, so we are going to use this formula right here. So this should not be A, that should be P. So A is equal to 4,800 times E raised to the 0.065 times 3 power. So I'll type this in to the calculator again so you can see how it's done. 4,800, then second, and this ln button, which is to the left of the 4, and then 0.065 times 3. And we get $5,833.49. So A equals $5,833.49. Then our last example, you deposit some money in a bank account 8 years ago. The bank paid 4% annual interest, so R is 0.04, compounded continuously. So again, don't be fooled by annual interest. You have to look for the word compounded. This is compounded continuously. So that means we're going to be using the same formula. Today, you have $1,200 in the account. So P equals 1,200. How much money did you invest 8 years ago? So that means T is equal to -8. So A is equal to 1,200 times E raised to the 0.04 times -8. So type that into your calculator, and you should get $871.40. So that will be your answer. So I'm hoping that you're feeling more comfortable with these formulas. The hardest part is really dissecting these problems and saying, okay, which formula do I use in this problem, and what are the key words that we're looking out for? You know, in compounded continuously problems, we are looking for the word compounded continuously. If we don't see the word continuously, but just see compounded monthly, quarterly, yearly, semi-annually, that means we have to use the formula from the other day with the N in it. If we don't see the word compounded at all, and something just grows by 6.5%, but we don't see the word compounded, we use the traditional exponential growth formula or decay formula, the A equals P times 1 plus R to the T power. You know, if you don't see the word compounded, you would use that formula. So it will take practice reading these word problems and dissecting them and underlying information, and that will make setting them up easier. And then once they're set up, you just plug it into your calculator and give us that answer. So thank you for watching the video. Make sure to like it and subscribe.